Infrared thermography is one of the most important sensing technologies to be applied to the detection and monitoring of manufacturing and production equipment. Until recently, this sophisticated technology was prohibitively expensive, being driven primarily by military applications. Over the last few years, however, the technology has improved, and it has been introduced to high-volume commercial and professional applications by innovative companies such as Wohl. This has brought the price down to a level which is opening up a host of new applications. Thermal imagers measure the infrared energy emitted by surfaces remotely and are consequently extremely simple to operate as no physical contact is necessary. Many facilities have employed thermographers to carry out inspections every 6 or 12 months. The cost of the equipment and its ease of use mean that these inspections can now be carried out as and when required by the organization's own maintenance staff. Appropriate thermal imagers no longer need to cost $45,000 or more. For example, the comprehensive range of imagers from Wohl starts from less than $2,500, less than the cost of a single survey from a thermographer. It is the affordability of the current generation of imager. Infrared was discovered in 1800 by Sir William Herschel as a form of radiation beyond red light. These infrared rays, infra is the Latin prefix for below, were used mainly for thermal measurement. There are 4 basic laws of IR radiation: Kirchhoff's law of thermoradiation, Stefan-Boltzmann law, Planck's law, and Wien's displacement law. The development of detectors was mainly focused on the use of thermometer and bolometers until World War I. A significant step in the development of detectors occurred in 1829, when Leopoldo Nobilis, using the Seebeck effect, created the first known thermocouple, fabricating an improved thermometer, a crude thermopile. He described this instrument to Macedonio Melloni. Initially, they jointly developed a greatly improved instrument. Subsequently, Melloni worked alone, developing an instrument in 1833, a multi-element thermopile, that could detect a person 10 meters away. The next significant step in improving detectors was the bolometer, invented in 1880 by Samuel Pierpont Langley. Langley and his assistant Charles Greeley Abbott continued to make improvements in this instrument. By 1901, it had the capability to detect radiation from a cow from 400 meters away and was sensitive to differences in temperature of 100,000ths of a degree Celsius. Human eyes can see objects that are illuminated by either the sun or another form of light at specific wavelengths in the visual spectrum. In contrast, thermal cameras see heat, or electromagnetic radiation within the infrared spectrum, emitted by objects. Infrared, IR, light is an electromagnetic radiation of small particles named photons. All objects at temperatures above absolute zero, minus 273 degrees Celsius or minus 459.69 degrees Fahrenheit, emit infrared radiation, and this is how heat is transferred and detected by IR, thermal, cameras. This is why a thermal camera can operate even in complete darkness. Though it's not visible to human eye, radiation of infrared energy can be felt. If you hold your hand close to the side of a steaming cup of coffee, you feel the heat emitting from the cup. Thermal cameras can see this radiation and convert it to an image that we can then see with our eyes. Medical thermography, digital infrared thermal imaging, DITI, is used as a method of research for early preclinical diagnosis and control during treatment of homeostatic imbalances. There are few devices which operate in a passive method like infrared thermography medicine. Amongst these are the ECG and DIG. The intrinsic safety of this method makes infrared thermography free from any limitations or contraindications. Thermography is a non-invasive, non-contact tool that uses the heat from your body to aid in making the diagnosis of a host of healthcare conditions. Thermography is completely safe and uses no radiation. Medical thermography equipment usually has 2 parts, the IR camera and a standard PC or laptop computer. These systems have only a few controls and relatively easy to use. Monitors are high-resolution full-color, isotherm or grayscale, and usually include image manipulation, isothermal temperature mapping, and point-by-point temperature measurement with the cursor or statistical region of interest. The systems measure temperatures ranging from 10 degrees Celsius to 55 degrees Celsius to an accuracy of 0.1 degrees Celsius. Focus adjustment should cover small areas down to 75 by 75 millimeters. Infrared thermal imaging is wonderful, but given its inherited nature, is impacted by the weather. You can no more take the image outside on a beautiful hot sunny day than you can on a cold dreary, rainy night. The conditions have to be just right to have the best possible image. This means cooler weather that is dry, low wind and the heat as the building is on. Also, at night is better for obvious reasons. If you try to just take the image, even simple things like the shade of a nearby tree can alter the reading and therefore make your results less accurate. There is little to no regulating body for infrared thermal imaging technology. There are some voluntary groups, but there's no vetting process. There is no required training when you buy the camera. There are the dangers of those who are over-equipped and underqualified making bad calls. Those bad calls impact not only those immediately affected, but the overall impression of reliability, or its absence of such. This is such a powerful technology, we need to. In conclusion, the thermal imaging procedure is a very beneficial device for both industrial and medical corporations and is seen to significantly improve in the foreseeable future for better usage,